Welcome to Carlton's Math Corner. Today we're going to be talking about the area of a composite figure. At this time, please make sure that you have your math journal as well as your vocabulary packet. First of all, let's look at some formulas that we have already learned, and I want you to notice any similarities between them. Do you notice anything that is similar between all of them? Awesome. Well, do you notice that the area of a rectangle, area of a parallelogram, area of a triangle, area of a trapezoid, and area of a circle, do you notice that all of them are multiplying two things together? So like rectangle, length times width, parallelogram, base times height, trapezoid or triangle, base times height, trapezoid, bases times height, and circle, we're taking radius or radii times pi. All of them have the similarity that we are multiplying two things together. I love that you made that observation. Today, we're going to be finding the area of composite figures. So we're going to be using all those figures. Every single one of them, we're going to use our knowledge of finding area of those figures. And we are going to be finding the area, we're going to be finding area of composite figures, which are made up of all those figures. So a composite figure is a figure made up of triangles, quadrilaterals, which are four-sided figures, semicircles, which are half circles, and other two-dimensional figures. So let's start off with a composite figure that looks like this. What could we do to find the area of this figure? Well, we could separate it into two parts so that we could, like if I separate this figure right here, do you notice that now I have two rectangles? And I could find the area of a rectangle because I know the formula for that is area is equal to base time or length times width. And so I could multiply them together, length times width in both categories. And then I would probably just have to add them together because then I could find the total area. So let's do that. In this rectangle, we have area is equal to 4 times, what's the other number? Would it be 8 or would it be something else? For those of you that said that it would be a different number, you are right because 8 actually is this whole bottom line. It's the distance, the length of this whole bottom line. And we don't want the entire line. We want only this portion of this rectangle. And so how do we find that just this portion? How could I find that? Well, if I want to find just this portion, I could look to the side and notice that this right here is equal to this because it's a rectangle. And I know that those two pair of sides are equal to each other. So if this is 3, then this is 3. So that means this leftover piece would be whatever remains after I take 8 minus 3 because I need to get the 3 out of there. And so 8 minus 3 is 5. So my missing side is 5. So let's take 4 times 5 and I get 20. And over here, this one is already set up for me because the side length and width, I don't have to make any changes because we need this entire side and we need this entire side. So we could take 3 times 7 and that is 21. And so now all I have to do is add these two together. 21 plus 20 and I get an answer of 41. And I'm going to label this centimeters because it's centimeters, but we are adding areas together. We're trying to find the total area, so we need to have centimeters squared as an answer. So there's my My answer is 41 centimeters squared. Let's look at the next one. So basically, well, let's look at steps. What we did is we separated the figure into smaller figures, okay, smaller pieces, and then we calculated the area of each small piece, and then we added them together. And those are our 3 steps that we did, okay? And you are welcome to write these down in your vocabulary notebook, or in your notebook. Okay, so here's our next one. Find the area of the figure. Well, to me, this kind of looks like a basketball court, or I guess a swimming pool. Could be a swimming pool, but it is made out of. I noticed that this is kind of a part of a rectangle, and this is part of a circle, and so I am going to separate it right here because I see that there's a rectangle and I might as well use that. And then I see that there is a semicircle, that means half of a circle. And so what I'm going to do is we're going to find the area of this portion. Well, I can take 11 because 11 basically represents this straight line. That is my length times my width, which is 6. And so I get 66. So far we have 66 inches squared. But now we got to figure out how to do this portion of a circle. Well, I know that to find the area of a circle, let's go back to our formula again. Remember, it is taking pi times radius squared. And so I'm going to use that formula in this case. And so I'm going to take pi times radius squared. And I need to figure out, though, what is radius? Well, the radius, remember, is halfway through the square to the center, or through the circle to the center. Okay, so look at this. That means if I had a full circle, if I continued this circle all the way around, and I started from the outside and I went to the center of it, this would be about the center all the way out. I would need to figure out how much this is because that would be my radius. Okay. Well, how could we figure that out? How? Because there's no numbers here. So what do I do? Yeah, use the information that's straight across from it. Do you notice this creates a rectangle? Remember, rectangles, they have 2 equal sides. So there's 2 pairs of equal sides. So that means this is 6. So that means this is 6. This whole length is 6. So how do I figure out just this part? Because that's our radius. Yeah, take half of it. 6, half of 6, or 6 divided by 2 is 3. So we have 3 inches. So we're going to do 3 squared. Well, what does 3 squared mean? 3 times 3. Perfect. And then we need to multiply by, whoops, I didn't mean to do that. We need to multiply by pi. Now, in your homework assignment, instead of hitting the pi key, we're going to actually use an approximation for pi. We are going to use 3.14 because that is a close approximation. It's not the exact amount, but it's a close amount. And so we're going to use 3.14 times 3 times 3. And so let's put that in our calculator. Let's do 3.14 times 3 times 3. And I get 28.26. And remember, our label for area is inches squared, but I'm not going to do that yet because I'm not even done. Remember, this area, 28.26, is for a full circle. A full circle. Do we need a full circle? No, we only need half the circle. So I can't use this full amount. I need to take half of it. Okay, so how do I take half of something again? Yeah, divide by 2. Okay, so let's take the calculator. Let's divide this by 2. Divide by 2, and I get 14.13. 14.13. So all this work that we did, I'm going to move it out of the way. And I am going to put 14.3 as our half circle or our semicircle. Now, if I know that this is 14.13, this semicircle, and this rectangle is 66, I need to find the total area though. So what do I do with the numbers? Exactly, I add them together. So let's add them together, and our answer is 66 plus 14.13. We get 80.13. And now I'm going to put inches squared. Okay, so we found the area of the rectangle, found the area of a whole circle, but then we took half of it because we only need half, and then we added them together. Nice job. How about this one? We have, well, this case, this is already separated for us into two figures, this composite figure. We have a rectangle and we have a triangle put together. So let's figure out, let's do the rectangle first, because that seems to be the quickest one. We can take 18 times 12, and 18 times 12 is 216. Okay, now let's do the triangle. How do we figure out, remember it's base times height. Well, we don't know either one actually because there's no numbers next to this triangle, so we need to figure them out. How do I know, first of all, the height? Yeah, the height is the same as this length over here. So I'm going to use 12 because remember a rectangle is the same on, the two opposite sides are the same. So I can use the 12 as this. But how do I know what the base is? Yeah, 24 is for the whole bottom, like the whole length, including the rectangle and the triangle is 24. So we need to figure out a way to figure out what this little piece is. Well, I like to use, excuse me, I like to use highlighters because I want you to see this is the part that we need. We don't need this extra space over here. So how do we get rid of it? Yeah, we take it away. How much is this extra space? It is 18. So let's take away 18 from our 24. Let's get rid of it. And the reason why I know it's 18 is because this is 18. And so straight across they are equal. So let's take 24 minus 18 and we get 6. So our base is 6. So I'm going to take 12 times 6 and that is 72. But what else do you have to do besides doing base times height? Yeah, we got to take a half of it. So what's half of 72? It is 36. Now, we have the area of 36 and the area of 216. What do you do with those two? We're going to add them together. So let's add them together. 36 plus 16, and we get 252. And we know it's feet, so we're going to do feet squared. Okay, so let's look at our ticket problem for tomorrow. What I would like for you to do is to figure out how much area is this semicircle as well as this rectangle together. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.